Hello guys! Alright, so I want to go over the quiz retake assignment for anybody who has questions on any of this information. So for number one, we're just going to dive right in. Number one is list and describe all 5 spheres. So you should have atmosphere is the air, anthrosphere is humans, biosphere, all living organisms, geosphere is rock, okay, dirt, soil, all that good stuff, and then hydrosphere is all the water in its liquid, gas, and solid forms. You need to include all that, okay? You should have a little bit more information on here. Kind of what we had in our notes would be a good source of where I would look to get the information that you're looking for, okay? So you needed to be able to describe these, and that way when I give you a description, you can pick which sphere it is, or when I give you a sphere and I give you a bunch of descriptions, you can match it correctly. So that's why we're going over that. Number 2, draw an exponential and logistic population graph and label the carrying capacity. So we have exponential, and then we have this is your carrying capacity, and this is a logistic growth curve. Okay? Alright, list and describe the abiotic and biotic factors that affect carrying capacity. So, some of them, of the abiotic ones, would be temperature, water, natural disasters, and there's more. There's tons in our notes. Go ahead and look through your notes. I would describe, don't forget it says describe how the factors affect carrying capacity. So if I give you a question of saying it's 80 degrees in June, it's 110 in July, and 120 in August, and 110 in September as to average temperature, which is that an abiotic or biotic factor affecting the carrying capacity? And hopefully, if I give you all that information, if I describe a situation, you can pick what it is, if it's abiotic or biotic. Biotic will be your competition. There was the 4 that we listed. Disease, predation, etc. And you need to be able to describe them, okay? So don't forget that. And this is on your notes page. I can tell you which page exactly in just 1 second. Not page, slide number. Hold on 1 second. I should have pulled it out sooner, sorry. Okay, so we have density dependent factors. Okay, there are the 4 types right here: competition, predation, parasitism, and disease. Be able to describe those. Those are your biotic factors. Okay. Number 4 is asking you to use the data of a fake virus and what is the average case fatality rate. So this one here has 2 correct answers, believe it or not. And the first thing you're going to do is you're going to take 1 divided by 15 and multiply that by 100. And you get a percent of 6.7%. Same with this one, 10 divided by 100 times 100 gets you 10%. Sorry, I forgot my percent sign. 125 divided by 500 times 100 gets us a percent of 25%. Okay. 523 divided by 2500 times 100 gets you a percent of 20.9%. And then we take 1379 divided by 5575 times 100, and that will get us a percent of 24.7%. And then 1176 divided by 4982 times 100 will get us a percent of 23.6. Okay. the first way, so way number 1, is you're going to add up all the percents, all the case fatality rates, all case fatality percents, and divide by 6, because there's 6 of them. 1, 2, 3, 4, 5, 6. That will equal a percent of 18.5%. Okay? Way number 2, which according to Mr. Kamine, one of our chemistry, physics, and math teachers, the other way is you can add up the number of deaths and divide by the sum, which is the total of total cases. Alright, so if I were to add this column, each column up, I would get, for this one, 3214, and for this one, I would get 13,672. So this would mean you would take 3214 divided by 13,672, and that would get you 23.5%. So both of those answers would actually be correct. On a multiple choice quiz, I would make sure only one of them was actually an option for you, so you would know obviously which way to do the calculating. According to him, this is way number 2 is the more mathematically accurate way, but both ways are correct. Okay? Number 5. All right, so looking at our prey curve, our prey population curve, and our predator population curve, one of the things that you should notice is that your prey population increases before your predator population increases. So prey pop increases before predator pop increases. Now, predator population will increase after a prey population because there's more food. Then, as more predators are present, more prey become food, and the prey population goes down. Now there's actually, believe it or not, some other factors besides just them getting eaten that accounts for the decrease in population size. One of the factors is, and I just actually saw this on a video on Nova last night, is as the predator or prey population becomes aware of the increased number of predators, they are on alert more. If they are on alert more, looking around, monitoring, making sure they're not going to get eaten, they are not eating as much. If they're not eating as much, then they are not able to reproduce as much. So it's partly, the decrease is partly because of prey being eaten, but it is also partly due to just the presence of the predators causing them not to eat as much, making them unable to reproduce as much. So that is a secondary cause of the decrease in prey population. I would not expect that in this answer box, but I would expect these two things. Similarly, you could also say as the prey population once the prey population decreases, the predator population decreases as well, and that would be because there's not as much food available for the predator population. Okay? So you should have something along those lines. Let's look at number 6, which says, it's blurry, sorry, there we go. Consider the food chain. Phytoplankton to zooplankton to krill to fish to seal to polar bear. You don't even actually need this diagram, okay, from the food web here. Identify the organism that contains the most biomass of the food chain. So what I would do, one of the easiest ways to do this, start with your pyramid. Okay, we have our phytoplankton here, zooplankton here, krill, I'm going to run out of room, fish, seal, and polar bear. PB is polar bear, not peanut butter, okay? If you remember the 10% rule, the most energy is stored at the bottom of the pyramid. Is at the bottom of the pyramid. Okay, so right here, all you have to do is know that the phytoplankton has 100% of the energy, okay, or biomass. Okay, actually this one's asking for biomass. Of the biomass. And that means there is way more plants or phytoplankton than there are polar bears. The amount that is needed to support this food web means that there has to be the most down here. You can't have the most at the top because there's not enough food then to support. If it's only getting, let's say this is 100%, so this is 100%, this is 10%, this is 1%, then this is 0.1%, 0.01%, and then the polar bear gets 0.001% of the energy from the phytoplankton. So if you have a ton of these, there has to be a lot more of this in order to support the population size. I hope that's making sense. I'm not sure I'm making 100% sense, but it makes sense in my head, so hopefully that makes sense to you guys. The lower you are in the food chain, the more energy you have, and the more biomass. So most energy, I'm going to make a note of that. Most of the energy and biomass of a food web, or a food chain in this case, is at the bottom. It's the producers. Okay, hopefully that makes sense. I would definitely know this. Okay. Alright, next question. Same food chain, okay? Identify the primary and secondary consumers from the food chain. So you can draw it out again, just like we did up here. Okay, if you do that, it's really simple. You just say, okay, zooplankton is primary producer because this is your primary producer. Zooplankton is your primary consumer. Krill is your secondary consumer. Fish are your tertiary consumer, and it goes up from there. So I'm going to just draw a blank one out with it just labeled primary producer, primary consumer, secondary, and tertiary. I'm only going to worry about 3 levels, okay? So we have primary producer, primary consumer, secondary consumer, and then tertiary. Okay? So that means identify the primary consumer. Primary consumer is, in this food chain, is zooplankton. Okay, this is the second thing on the list that we had in the above triangle, or you can look at it right here. This is your second one. So primary producer, primary consumer. That makes our secondary consumer our krill. Okay? Alright. Oh boy, we get to do this food chain again. Okay, consider the food chain of phytoplankton to zooplankton, the same one, okay? About how much of the chemical energy fixed by photosynthesis of the phytoplankton, assume it is 100%, is available to the seal. Okay, so we actually did this already up above, but we're going to go ahead and write it out in the chain form so that you don't always have to put it in a pyramid if you don't want to. Phytoplankton at 100%. Zooplankton at 10%, only 10% goes up. That's terrible. Sorry, guys. Krill then gets 1%. After krill, we're going to kind of loop it around and just kind of work our way backwards. We have fish So what's 10% of 1? 0.1%. After our fish, we have our seal, and 10% of 0.01 is 0.01%. We're just moving the decimal place over 1 because we're getting less and less of the original amount of energy and biomass stored in the phytoplankton. Okay? All right. Consider the food chain again. Assume the krill obtains 150 kilocalories of energy. How many kilocalories will the other organisms in this food chain have? Okay, so let's do it. It's probably easiest to do it on a pyramid. Okay, phyto, zoo, krill, fish, seal, and polar bear. Alright, so we know our krill has 1,500 kilocalories. So moving up, what happens? As we move up away from the primary producer, we get less and less kilocalories moving up. So we drop a 0. So this fish is going to get, each fish is going to get 150 of the original kilocalories, which means our seal, drop another 0, is going to get 15 kilocalories, which means our poor polar bear is only going to get 1.5 kilocalories from the seal. Okay, the zooplankton is down the pyramid, so we're going to add another 0. So this one is 15,000 kilocalories. Then we're going to have to add another 0 for the phytoplankton, and that's 150,000 kilocalories. Okay, so hopefully you can figure out as you go up the food chain, you lose a 0. Okay, going down, you gain a 0. All right. You can also, I mean, if you want to, it's really, you're losing 90% of your energy moving up. You're gaining 90% more as you go down, okay? If you want to look at it in terms of 90%. All right. I hope that helps clarify this for everybody for the quiz on Monday at 10 a.m. If you have any questions, email me. Thanks so much. Bye.